All right, what's up, everyone? This is going to be nuclear radioactivity works uh nuclear decay nuclear decay PDF. Um, all right, let's get on with it. So the first part is just like naming the like what are all the isotope symbols. Um, there are five of them. Um, well, not really. There's only alpha, beta, gamma, but these are just all the symbols for it. So alpha is just going to be helium, right? These are in the lecture slides. Or I'll even pull it up too. What slides are these? Oh yeah, you can pull it up on the slides, but I'm gonna just go through this quickly. All right, beta decay. Um, it's always an electron being ejected. That's beta decay. Gamma, the symbol is Y, and there's nothing has changed because it's a neutron injected, I think. And so yeah, neutrons. Oh wait, no, I'm I shouldn't say anything. Yeah. Um, yeah, gamma is just nothing's being ejected. Uh, something's being ejected, but the mass and atomic number changed. Positron decay, it's the same thing as electron, but this time it's electron capture. Neutron, uh, mass number it's 1, 0. Our nuclear change, for beta decay, uh, beta decay happens when there's too many neutrons. So when there's too many neutrons, it goes to neutron or proton. All right. Positron decay. This one happens when there's too few protons or too few neutrons. So that means you get more neutrons. So it turns from proton to neutron. All right. Complete these nuclear charges. All right, so the first thing I like to do is to look at these numbers and to see what's missing. All right, so for the first one, it's 238 goes into 234. So 234 plus what equals 238, and that'll be 4. 90, 92, 92 to 90. 90 plus what equals 92? That will be 2. And then this isotope particle will be helium. You right. Um, uh, the second one, oops. This will be called alpha decay. All right, remember the next one. It's 234, 234, 234, right? Nothing's being changed here. And for the bottom number, it goes from 90 91. And so 91 plus what equals 90? And this will be -1. And so the only sign that is -1 is beta decay. E. All right, alpha decay. This is alpha decay. Now we need to find out the element. Um, so let me pull up a periodic table. There we go. All right. So 234 breaks down into 4 and something else. So that means like what plus 4 equals 234, and that'll be 230. And then 291 right here. So what plus 2 equals 91? That'll be 89. And the way you want to find out the element in the periodic table is to look at the bottom number. So 89. So you need to find something that's 89. Over here, so it's AC. Okay, sweet. Number four, uh, 220 breaks down into four. So what plus four equals 220? So it'd be 216. And then what plus two equals 86? So 84. So when you find an element that has something that's 84, and this will be uh polonium. Yeah. All right, sweet. Halfway through. All right, so 216 goes down to zero. So what plus zero equals 216? That'll just be 216. 84 breaks down to negative one. So what plus negative one equals 84? 85. Right, because 85 minus one equals 84. Sweet. All right, now we need to find something that has 85. That would be AT, time, acetine. I don't know. All right. Um, Next one is six. Carbon breaks down to nitrogen. So 14 to 14. So what plus 14 gets 14? That'll be zero. Um, and then six breaks down to seven. So seven plus what equals six? Negative one. Because seven minus one equals six. And so as you see here, this will be a beta decay. So you're gonna write E right here, and then a beta decay. Beta decay. All right, next one. BI breaks down into what's this here? Beta decay. So one of them is going to be E, 0 minus 1. All right, and then 210 breaks down to 0. So what plus 0 equals 210? This will be 210. And then 83 breaks down to negative 1. So what plus negative 1? Or what minus 1 equals 81, 83, 83? I'll just be 84. So let's find something that's 84. All right, let's so PO, polonium. Sweet. Oops. All right, next one. This one says it's going to be neutron bombardment with alpha emission. So this how we do this one is we add everything on the reactant side. So this will be 11 on the top, and then this one will be 4. So what plus 4 equals 11? Just 7. For the bottom numbers, this will be 5. This one will just be 2. So what plus 2 equals 5? This will be 3. So something that has an atomic number of 3 will be lithium. Our next one, number 9. Um, this is a positron decay with gamma emission. So a positron is ejected. Positron decay is so positron is ejected, so plus 1. All right, so now let's do the same thing we did earlier. So this side is 23. This side is 0 still, because 0 plus 0 is 0. All right, so the top number will be 23. The bottom number will be 12. This one will be just be 1. So what plus 1 equals 12, 11. Um, the atomic number of 11 is Na, sodium. Oops. All right, sweet. That's your nuclear decay worksheet. All right, thank you guys for watching. Later.